Let's have a little bit of music too, why not? A little bit of Musax, never does any harm. There we go. Let's do some of that. Okay, this is Just a Jolt here, and let's do some maths. Today we're dealing with surds, and so the first rule that we're going to go through, if we go over here, is illustrated by this question. Let's go to GCSE maths, let's go to algebra, let's go to surds, and we're going to have a look at the first surd rule right here. And this is all now level 7 stuff. So here we have, that's one of the surds times 1 over 11. Now this first rule, oh, that's a little bit loose. Let's tighten it up a little bit. There we go. Tighten up, tighten up, tighten up. There we go. Still a little bit loose, but hey, it's one of those things. Right, so the first rule that we're going to deal with is this one right here. And so what happens, how do you simplify this? So basically, simplifying something like this is very, very simple. It's just a case of saying 1 times 11, and then you can simply smash all that together and you simply have 11 in this case. That's a little bit of a boring example. Let's take a look with a couple of letters just to kind of illustrate the point again. So let's say you've got surd like that. So you've got root A times root B. A surd, by the way, is literally just the square root of something which isn't going to be a sensible number. That's pretty much it. So you've got root A times root B. So now you have root A times root B, all in the same surd if you like, and then we can simplify that again. We go AB, and that is the final answer in that case. So now we're going to take a look at a couple of examples, because that's probably the simplest of the surd rules. Still kind of classed as level 8 stuff though. Still classed as level 8, which is interesting. So let's go ahead and get another one of these up. Go. So we're going to go here, see what comes up this time. Oh, that's more interesting. So now we've got root B times root 7. So we've got root B times root 7. Okay, and again, just following exactly the same rules as before. This is pretty simple stuff. So let's have root B times root 7, just kind of all under the same square root right there. And then once more, we just got root 7b. Root 7b, putting the number there first. So let's just check that's the answer that I've got as well there. So there we go. So root 7b is the answer I got there too. Let's have another one. We got root c times root 12, and so again, just going through that, we've got root c times root 12. Yep. And so I'm now going to skip this part and I'm going to go straight to the end, which is root 12c. And just going back here just to check my answer there. And indeed we've got root 12c. Right, so let's go to the next type now. So I'm going to close this. And our next surd rule, oh, this is just dealing with letters, so it's the same one again, dealing with letters. So let's see if I can... There we go. So our next surd rule is, again, it's very, very simple. So this is what we've got. So in this case, we're not multiplying anymore. We're now adding. And this is actually kind of a trick question. And the reason it's a trick question is because if our surds are not the same kind of value, if they're not the same type of surd, we can't actually do anything to them. So in this case, root 7, oopsie daisy, I'm just going nuts today. Root 74 plus root 11. This is going to simply be root 74 plus root 11. There is nothing more to be done about this. So if you take a look at the answer there, there is nothing more to be done about this. It doesn't matter how many times we do this. In this case, why is this different? Well, let's take a look, shall we? We've got root 100 plus root 121. Well, you've got to be a little bit careful because in this case you've got root 100, and the square root of 100 we know is 10. Square root of 121 we know is actually, well, it's 11. So in this case, 10 plus 11 equals 21. So you've got to make sure that you're not actually dealing with something that isn't a surd. because a surd is something which isn't going to give you a whole number if you find the square root of it. So anyway, let's go back now and let's find another type of question. That's the same again, it looks like. There we go. That's a little bit more interesting. Fantastic. So I think we'll have a go at this. So what we've got here is, let's write that out on the board while you're writing it out too. There we go. So we've got a plus root d and all of that squared. Okay, now this is quite an interesting surd rule right here. Now I'm going to show you this. I'm going to show you this once, and what you're going to see is that actually, if you memorize the rule for this, it actually makes your life really easy, and you can just write it out straight away. But I'm going to show you how it works. So let's have a plus square root of d, and then a plus square root of d. And the reason that we can do this is because obviously these are the brackets squared, so you end up with this bracket times that bracket. So we're just going to expand these the same way as we normally expand brackets. So a times a is a squared. A times d, root d, is going to be a root d. Root d times a is a times root d, and then finally root d times root d. Now I am going to write it like this, but we're going to change that in just a second. So what you can see here is you've got two terms which are the same, and we can actually simplify those terms. So let's go ahead and do that. Let's simplify these terms. So both of these simplify into 2a root d. And the reason for that is because they're both exactly the same, so we can just say that there's two of them. So that's nice and easy. And then you've got root d times root d. Well, that's the same as saying root d squared. And if you look at this, then this is the opposite to that. So what we're actually doing is cancelling these out, so we end up with just d by itself. So that leaves us with a squared plus 2 root d plus d. And this is actually a pattern which works consistently all the time for this particular type of problem. So let's go back and let's have another one of these. Okay, so this time we've got d plus root I. So I'm going to scrub all this off the board quickly. There we go, d plus root I squared. It's on the board now. And let's take a look at that. So again, we can write this out as d plus root I times d plus root I. So writing it out like so. And then let's expand it. So d times d is d squared. D times root I is d root I plus d times root I again, d times root I plus root I times root I. So again, we can simplify this down, and bearing in mind what happened last time, we'd expect to end up with this d squared plus 2 something plus something. All right, and so it simplifies down. So let's have d squared plus 2 root I plus I, because remember that times that is going to cancel down to just that, and that's our answer. And if we remember that, if we memorize this, then we can actually go straight from that to this. So first of all, let's go and just check and make sure our answer is correct there. So there's our answer, and let's generate another one. And what we're going to do this time is try to go straight, directly to the answer without going through those middle points. So I'm going to write that out again. So we've got x plus root v and all of that squared. So this time we're going to go directly to our answer without going through anything else. So we're going to say that that's going to be x squared plus 2 x root v plus v. And we're going to say that's our answer without doing anything else. Let's take a look and see if that's correct. There we go. And that's what we've ended up with. We're not going to do one more of these because that's pretty simple. We're going to move on to the next type of surd rule. So let's see what we've got here actually. Nope, we're not going to look at that one. Oh, that's an interesting one. Let's do that one. So this is another type of situation which you'll get, which you'll need to be able to recognise. And what you have is u plus root b, u minus root b. And this is the same as the previous type of problem. It's simply a case of kind of memorising what happens, and then it makes your life very, very easy. And this one's even easier than the previous one, and I'm going to show you why that is. So let's expand this first of all. So you've got u times u is u squared. U times minus root b is minus u root b. And then you've got root b times u. But this is plus now. These are both positive. So we've got plus u root b. And then we've got, what's this? Root b times minus root b. So the square root of something times minus the square root of something. Well, we're going to get a negative answer here, aren't we? So let's just write it out and see what happens. I'm actually going to put this in brackets. Plus root b minus root b. So let's simplify this a little bit. So minus u root b plus u root b. Well, these are just going to cancel out, so these are gone now. They're gone. So what we're left with is this at the end. So plus root b minus square root of b. Well, let's use kind of a real example to understand what's going on here. So let's say that we're dealing with 4, a number we do know the square root for. And this makes it a little bit more, easy to understand what's going on. So remember, we're multiplying those together. So let's put those in brackets too. So you've got, what's the square root of 4? Well, it's 2. So you've got 2 times square root of 4 again, 2 minus, so you've got 2 times minus 2, so you're going to end up with minus 4. So in this case, the square root of b times the square root of b, well, that's going to be your squared sort of scenario, isn't it? But you're completely lost track of where I was right there. That's right, there we are. So these are both going to cancel out because we're multiplying them. And what you're going to end up with is the same as here. You've got negative 4. We're simply going to end up with negative b. So this one's even easier than the one before. Even simpler. So let's just do one more of those. And then I'm going to go and I'm going to take my kids for a quick walk. Because that's the one thing we're allowed to do to get some exercise. So let's get another one of these up. So we've got k plus root w, and then we've got k minus root w. There we go. It's all on the board there. And so now, without even going any further, without even doing anything to this, I know what the answer is going to be. I know it's going to be k squared minus w. Let's go and check that answer. And the answer is indeed k squared minus w. And we can do the same with this as well. So I know that the answer to this, because it follows the same pattern, is going to be h squared minus n, and indeed h squared minus n. So they are two square rules we've been through today. And the two square rules, just to recap, we just get the board out again there. Here we go. So the two square rules is if you see something like this, a plus root b squared, that's going to simplify down to a squared plus 2b plus b. And if you see something like this, a plus root b, a minus root b, that's going to simplify down to a squared minus b. And the other third rule that we covered, which was a little bit simpler, was simply root 3 times, let's say, root 5. The answer is going to be, in this case, root 15, because root 3 times root 5. Anyway, thanks very much for watching. This is Just a Jolt signing off.